Okay, for the second half of this section, we're looking at the composition of functions. Now, this, especially if you're unfamiliar with this, this could seem a little bit abstract, and so I'm not going to spend a whole lot of time on the top part here. We'll work through some examples, but essentially, the composition of functions is where you have two functions, and you're using one function as the input for the other function. So any function definitionally takes an input and gives a unique output. And usually the input is just the set of X values that you could choose from. Um, but in this case, we're going to look at the input as a function itself. And so this is a way to combine functions, and it can be a little bit more complex than just simply adding them. And we'll talk about, I kind of have written out here how you find the domain. We will talk about the domain in the examples. So essentially what this notation means, so this little circle is the composition, and what that means is that whatever the second function is, that is going to be the input into the first function. So in this case, G is the input, we're going to put it into F. In this case, F is the input, we're going to put it into G. So let's see what that looks like. So F composed with G, and this is, I think it might help if you write it like this. So this part is the input. So we're going to put this in for X right there. So the input is X minus 3. We're going to plug that in for X. And so we just have X minus 3 squared. And then do the reverse. So G composed with F of X. This is G of F of X. So now we're going to put X squared in for X right there. And so we get X squared minus 3. So now what's the domain? So the domain of both of these is all real numbers. And we're not super concerned about what the domain of the output function is. So we're more concerned about what the domain of this one is and what this is. And in both cases here, it's all real numbers. So nothing too serious here. So it's just all real numbers. We don't have any square roots or rationals or anything like that. So nothing too deep there. Now you could, so for this second part, obviously this is f of g of 5 and g of f of 7. And you can, of course, plug 5 into this one and get the answer. You can plug 7 into this one and get the answer. But I'm going to show you, if you're just asked to do this, you don't really have to find this part first. So what we can do, we can find g of 5. So we'll write this over here, g of 5, plug in 5, we get 5 minus 3, and that is going to be 2. So f of g of 5 becomes f of 2. All right, so that is that. G of 5 equals 2. And now we're going to plug 2 in for f. And so that is 2 squared, which of course is 4. And you can see here, if we plug in 5, we get 5 minus 3, which is 2 right there. And then 2 squared is 4. So we're kind of, if you have this, it is easier to do it that way. But my point is you don't have to find this part first if you don't want to. And sometimes it's not worth it. And these are pretty simple, so it's either way is equally easy, I think. But with more complex functions, it's probably easier if you're just finding a particular value, just plug it in without finding the overall function. So here, let's find f of 7. And of course, we're plugging that in for x. So that would be 7 squared, which is 49. Now we're going to plug the 49 in to g. So we have 49 minus 3, and we get 46. And you can see again, this does the same thing in the same order. Square the 7 and then subtract 3. And that's exactly what we did. So, but we'll see some where maybe it might be a little bit easier to just do this by itself. All right, so the next one, so let's look at these, find the following in their domains. So f of g of x. So we're going to plug 2x minus 1 in for that x and in for that x. So we have 2x minus 1 on top. Now this x, we're going to plug in 2x minus 1. And then we have the plus 1. And now it's just a matter of simplifying. So we have 2x minus 1 on top, 2x on bottom. Okay, so let's talk about the domain. What is the domain of the input function? That domain is all real numbers. What is the domain of this? We just consider this as a function. That would be all real numbers except for 0. So the domain of the composite function or the composition is where this domain intersects with that domain. So in this case, that's all real numbers, so we really don't have to worry about that one. This one is all real numbers minus 0. And so that is the domain of the function. All right, what about g of f of x? So do it in reverse. So now we're going to plug x minus x over x plus 1 in for this x. So we have 2 times x over x plus 1 minus 1. And let's see if we can simplify this. Let's find a common denominator. So common denominator would be x plus 1. We're going to multiply 1 times x plus 1 on top and bottom. So we have minus x plus 1 and then all over x plus 1. Then now just combine like terms. So we have 2x minus x. That gives us x, and then minus 1 and then over x plus 1. All right, so now what's the domain? So the domain of this one is, so we had 1 in the bottom, so we got to take out negative 1. So negative infinity to negative 1, union negative 1 to infinity. And this one is actually the same. So we have the same denominator. So that one makes this one easy to find the domain. All right, next we have f composed with itself. So f of x. And so now for each of these x's, we're going to plug in x over x plus 1. So in our numerator, we have x over x plus 1. In our denominator, we have x over x plus 1 plus 1. So there, x over x plus 1 is the original function. And we're plugging in that in for each x. So now let's simplify. And we'll leave the top alone for a minute. And then we're going to get the common denominator. So x right there plus, and then we're going to have to multiply this one times that new denominator, or the common denominator, I should say. All right, so now if you remember in the first part of this section, we talked about dividing fractions, which I'm sure you know. But essentially, these x plus 1s are going to cancel out. And then we're going to have x over 2x plus 1. So x and then 2x plus 1. So now what's the domain? So we have the domain of f here. The domain of this one, and we're going to write this here. So the domain of that, we need to figure out where this is 0. So the denominator would be 0 when x is negative 1/2. So the domain would be negative infinity to negative 1/2, union negative 1/2 to infinity. So now, so these two were pretty simple for finding the domain. There wasn't too much to think about. So we know that that is the domain there. And this is the domain of that function. So we need to consider what are the inputs that we could put into this function and what are the valid inputs for that function and overlap them. So the domain of the composition would be negative infinity. So basically, essentially, we need to take out negative 1 and we need to take out negative 1/2. So negative infinity to negative 1, union negative 1 to negative 1/2, union negative 1/2 to infinity. And that is the domain of composition. So the reason for that is you cannot just look at the simplified function to find the domain. You have to consider what are the possible inputs to begin with. So these are the possible inputs to begin with. Now, are there any in here that would not work in the new function? And so considering all these, the only one we have to take out from this set is -1/2, which we do here. All right, so then g of g, so g of g of x. So now we're going to plug in 2x minus 1 in for the x in that. So we get 2 times 2x minus 1 minus 1. And so that gives us 4x minus 2 minus 1, so 4x minus 3. And then the domain of this one is just going to be all real numbers. So we don't have anything to worry about in this. So we just have a linear function plugged into a linear function. And so that's just going to have a domain of all real numbers. So make sure if you have trouble, study this one. Make sure you know how to get that domain, because that's the kind of the tricky one in this problem. And it could be, it's not just because it's f of f. It could be any of these, but it happens to be this one. So make sure you know how to get the domain when the input function is not all real numbers and the output function is not all real numbers and it's not the same as the input. All right, and the last one, these are just a couple of kind of unusual examples, maybe not unusual, but not as obvious, I guess, at first, although they're not too difficult. So f of g of 2, so we have a graph of f and g. We need to find f of g of 2. So let's find g of 2. So here's 2, 2, 3, 4, 5. So g of 2 equals 5. So now we need to find f of 5. So f of 5, 2, 3, 4, 5. 1, 2, 3, 4 is 4. All right, so that's all you're doing. So you start at the input, figure out what that value is, and then plug it into the output. G of f of 4. So what is f of 4? 3, 4. F of 4 is 2. So we need to find g of 2. And we already know from this one, g of 2 is 5. All right, and then last one, g of -2. So what is g of -2? So that would be 1. So we need g of 1. G of 1, 1, 2, 3 would be 4. Okay, so those are, I think, are pretty easy once you get the hang of them. Nothing too hard. Just pay attention to which one is the input, which one is the output, because it definitely could change. And then the last example, this one's similar to the graph. Here we have a table, and so let's find f of g of 2. And so what is g of 2? G of 2 is 5. So g of 2 is 5. We need f of 5. So here's 5. F of 5 is 6. Find f of 1. So what is f of 1? F of 1 would be 2. So this is f of 2. And then what is f of 2? F of 2 is 3. And then the last one, f of g of 6. What is g of 6? G of 6 is 4. So f of 4. F of 4 is 1. Okay, so not a whole lot of math in this. It's mostly just knowing how to read the problem and knowing what the notation means and that kind of thing. All right, so if you have any questions, feel free to email me.